Assalamualaikum and a very good day to Dr. Siti Hidayah binti Muhammad Saleh and Puan Rosha binti Muhammad. I, Fatin Nor Syafawani binti Abd Rahman, really as the presenter one.
My name is Paula Lenja, anak alias Amit, and I am a presenter 2.
And I'm Adila binti Ismadon as presenter 3.
We are from group P08M21. We'll be presenting a study entitled Solving Fitzhugh-Nagumo Equation using the Semi-Analytical Method SAIM. Our group are supervised by Dr. Saleh bin Slamat.
So this is our presentation outline.
Fitzhugh-Nagumo equation has been widely solved for this past year using other method. However, it's yet to be done by using the SAIM. Therefore, implementing the SAIM for solving FN equation was conducted. This study used the SAIM and the absolute error formula to evaluate the SAIM accuracy when implementing into FN equation by applying 4 different cases. It proved that SAIM is simpler and more straightforward to solve the FN equation compared to other method, although it has bigger error.
The Hodgkin-Huxley equation was reduced by Fitzhugh due to its difficulty and then continued by Nagumo with the study of nerve excitation and conduction. The Fitzhugh-Nagumo equations, which model nerve impulse transmission, is the important key for study of nonlinear reaction dysfunction equation. In order to solve these nonlinear problems, a method that was proposed by Tamimi and Ansari, which is also known as Semi-Analytical Iterative Method (SAIM), is used. This method seems quite accurate, efficient, and reliable. This research study is trying to solve Fitzhugh-Nagumo equation by implement the Semi-Analytical Iterative Method introduced by Tamimi and Ansari. This iterative method has been used solution for various problems related to differential equation to evaluate the exact solution and the approximate solution. Some of the related problems are the Newell-Whitehead-Segal equation and non-linear problem.
Problem statement. Other methods used to solve Fitzhugh-Nagumo equations such as variational iteration method, BIM, Adamian decomposition method, ADM, and homotopy perturbation method, HPM, and its calculation is quite burdensome. Besides, the conversion of the iteration method that is extremely hard to achieve. Objectives. The first objective is to solve Fitzhugh-Nagumo equation by using Semi-Analytical Iterative Method, SAIM. The second objective is to evaluate the effectiveness and accuracy of SAIM when compared with the exact solution and by other methods such as BIM, HPM, and ADM. Significant and benefit of study. To find the simplest method for solving Fitzhugh-Nagumo equation. Scope and limitation of study. This project was conducted to show the efficiency of Semi-Analytical Iterative Method, SAIM, towards the Fitzhugh-Nagumo model. The limitation of study is limited references and information on this topic.
Next, let's move on with the latest review on the summary of discovery of Fitzhugh-Nagumo equation. It started when the Van der Poel discovered the heartbeat equation that depends on the idea of relaxation oscillation system. Then, it was continuously improved to simplify until FN equation was proposed with the more familiar active summation. Below is the general formula of Fitzhugh-Nagumo equation. As been stated, the FN equation has been solved by other methods. The most methods used is the Semi-Analytical Method by Deegan, such as the Adamian decomposition method. In the same year, Jawad proposed modified simple equation method to solve the FN equation. SAIM was first found by Tamimi and Ansari in 2011, which inspired by homotopy analysis method. Comparing to the homotopy perturbation method, numerical result of SAIM has a great accuracy and faster convergence. This is proved to be successful in solving complex problems. Because of its direct and more straightforward, it has been applied to solve many equations. One of it is differential algebra equation, which has better accuracy, even though SAIM is using smaller number of iterations.
Next, methodology and implementation. There are 3 main phases involved in the study. The steps and flows are shown here. First, analysis of SAIM. This is the flowchart of the solution of the equation, which consists several steps as follows. Step 1. Consider the general equation. It has been noted that it is possible to take any or all of the objective function and apply to nonlinear operator n. The right choice of these paths depends on the basis of the trial. Step 2. Assume solution of equation for initial condition. Step 3. Find iteration. Step 4. By solving the following problem, an iterative procedure can be created. Phase 2. Implementation of SAIM into Fn model. Step 1. Consider the general equation of Fn. Step 2. Implement SAIM into Fn as the equation follows. Step 3. Solve the primary problem. Step 4. General iteration problem can be done through the following. In Phase 3, evaluate the accuracy and effectiveness of SAIM to solve Fn model. To evaluate the accuracy, the formula is given the value of exact solution minus the value of F's promised solution. Next, the result and discussion. There are 4 different cases with different parameters that will be solved. The value of x will be set on 0.0 until 1.0 with distant t-value. Case 1 shows alpha equal to -140, 0.5 and 0.5. Both tables show the comparison between SAIM and the exact solution as the absolute errors between them is increasing. It shows that the best solution of SAIM has smaller value of x. Case 2 shows comparison at alpha equal to 1/3 for t equal to 0.25 and 0.5. Both tables show the absolute error has also increased along with value of x. Although the value shows SAIM is obtaining near the exact solution, it still does not miss the exact solution when the value of x increases. Case 3, table shows alpha equal to 2/3. The absolute error also increases along with value of x for t equal to 0.25 and 0.5. From case 1, 2, and 3, it can be concluded that the value of t should be bigger to solve using SAIM along with increases of x in order to get the better accuracy.
Lastly, case 4 is solved by using the same method as previous cases but with different parameters. The first parameter is alpha equals to 1 with the t equal to 0.75. The table and graph shown the comparison between absolute error of SAIM in the second iteration, UiTM, HPM, and ADM. It has been highlighted with only the second iteration, SAIM has nearly achieved the same error and sensitivity of the other method. The table and graph shown the comparison of absolute error of SAIM, UiTM, HPM, and ADM with parameter alpha equal to 1/4 at t equal to 1. SAIM has the biggest error compared to the other methods. Apart from its biggest error, SAIM only solved by 2 iterations compared to other methods that require Lagrange multiplier and Edomian polynomial.
The last one is case 4 for alpha equal to 1/9 and t equal to 2 at x more than or equal to 0.0 and less than or equal to 1.0. So here, it shows the table and graph for comparison between absolute error of SAIM, VIM, HPM, and ADM. From the graph, it explains that the approximate solution obtained by VIM is 0, which is accurate. As well, the solutions are still the same obtained from ADM and HPM. Furthermore, it indicates that absolute errors of SAIM, ADM, and HPM are better compared to the exact solutions. So here is the conclusion. The first objective is to solve the Fitzhugh-Nagumo equation by using SAIM is successfully achieved. To get an exact solution, SAIM is considerably simpler to apply for solving Fitzhugh-Nagumo because it is straightforward. It also does not involve any restrictive assumptions when dealing with nonlinear terms. The second objective, which is evaluate the effectiveness and accuracy of SAIM when compared with the exact solution and by other methods, are also successfully achieved. Although VIM, HPM, and ADM are less degree of accuracy and efficiency compared to SAIM, the potential solution by SAIM often managed to approximate the accuracy and the efficiency towards exact solutions with the biggest error among the other methods. Next is recommendations. Semi-analytical iterative method SAIM can be applied to other selected cases of the Fitzhugh-Nagumo equation. It can be the exemplary form of another numerical method that is appropriate and practicable. And the next slide is our references.
That's all from us. Thank you.